Now proceed to our lectures on the loadings. So for problem number 6, this is an example of the dead load calculation. So as we can see here, we have a girder that is made up of two material, that is stone concrete, plain stone concrete, and steel reinforcing bars, or cold form steel reinforcing bars. So again, we are going to refer to our table on the dead loads, or the minimum densities for design dead loads. So as for the concrete reinforced stone, we are English, we adopt 150 for that, and then steel cold drone 492 pounds per cubic feet. So normally we are going to use the formula of weight in terms of gamma. So we're gonna write that those criterias. Okay. So we have gamma for concrete, that is equivalent to 150 pounds per cubic feet, and then gamma for steel equivalent to 492 pounds per cubic feet. Okay, for this one, of course, we are going to determine the volume, and the volume is per foot of this length. So basically, we start with the calculation of the cross-sectional area of each of those material. And remember that the concrete area should be reduced or deducted. We should deduct the area of steel occupied by the space provided by the steel. Okay, so first we are going to compute for the cross-sectional area of the steel, and that is 4 pieces and a circular one. So we have here 3/4 0.75, that is squared. So we will be having here a area for steel in terms of feet squared, or sorry, inches squared. So we have here 1.77 square inches. And of course, we will convert this in terms of feet for consistency. So there are 12 inches in a foot. So all of this will be raised to 2. Okay, that we will cancel that one. Okay, so area of steel will now be in terms of square foot. Okay, we have 0.0123 feet squared. Okay, so we are done with the steel. Next, we have the concrete. So as for the concrete, the easiest way to do that is to consider a rectangle minus the two trapezoidal section within both sides. Okay, so we will do that. So we have now, perhaps we can delegate that as the gross area for the concrete. Why we name it as the gross? Because by and by we're going to deduct the area of steel, because there are spaces that was occupied by the steel. Again, AG. Okay, so we have the area of the rectangle less two areas of the trapezoid. Okay, trapezoid. So the area for the rectangle is 14 by 48 if we look at the figure here. And then the trapezoid is given by the formula b1 plus b2 over 2 times the height. So we have two of them, and then we have 20 plus 32. Okay, 20. Okay, b1 plus b2, this one, all over 2. Okay, what is the height of the trapezoid? We have 4 inches. Okay, so 4 inches. So that we will obtain now the gross area for that concrete. We have here 464 square inches. Okay, that is 464 square inches. Now we will have to compute for the area of the concrete, or the net area of the concrete. That is the gross area minus the area of the steel, because again some spaces were occupied by the steel. So we have here 464. So we refer to what we have calculated a while ago in terms of square inches. We have here, obviously, we have 1.77 for that one. Okay, so 1.77, we have 462.23 square inches. And again, we are going to convert that one by dividing it by 12 squared. Okay, so that we will come up with the feet squared unit. Okay, so 462.23 divided by 144, that is equal to 3.21 square feet. Okay, so knowing the areas of the concrete, we are now ready to determine, of course, the weight of those material. Starting with gamma of concrete 150, we have gamma of concrete is equal to 150 pounds per cubic feet. Okay, so the weight is gamma times volume, we know that. And here, per foot length, we have W is equal to the area, gamma times the area times per foot length. Okay, 1 foot. So we have here now 150 times 3.21, first times 1, then we will be having 481.49 pounds. So if we wanted to make it a distributed load, we'll just have to divide it by a feet. Okay, 1 foot. This is pounds. So it remains to be that. So this is the weight per foot of that concrete, for that concrete. Okay, so for steel, okay, so may we just place it adjacent. For steel, we have gamma for steel is equivalent to 492 pounds per cubic feet, and then just the same, similarly, we have W is equal to 492 times the area we had computed a while ago. I think that is how much? 0.0123 feet squared. 0.0123. So we have 0.0123. So we calculate that one. We have W is equal to 6.05 pounds. Okay, so again, small w for distributed load, we have 6.05 pounds per feet. So this will be the weight of that steel. So as for the summation, the total load of the girder, so the weight of the girder is equal to 6.05 plus 481.89. We have 487. Okay, pounds. So the distributed load of the girder per foot is equivalent to 487.94 pounds per foot. So this is the answer in the problem number 6. Okay, so for the 7th problem, we have here a wall. So it is defined by its material. First, we have 0.51 mm by 102 mm studs plastered on one side. On the other side is 13 mm fiberboard. So we have three materials here. So as we can see here, these are studs, and studs used to hold the board as well as the plastered. So on this studs, we have a surface that is consists of plastered on one side. On the other side is a 13 mm fiberboard and 102 mm clay brick. So there will be how many material? Number 1, we have studs. Okay. Number 2, we have 13 mm fiberboard, and the third one, 102 mm clay brick. Okay, clay brick. So let us refer again to our table for that. For studs, we note that 51 by 102 plastered on one side, 51 mm by 102 mm plastered one side. Okay, where's that? 51 by 102 plastered one side, that is equivalent to we are in SI unit, so we're gonna pick here plastered one side 0.57, and then 102 clay brick, 102 clay brick and 13 mm fiberboard. So here it is, 1.87 for 4 inches clay brick and 13 mm fiberboard. So let us place those one. 0.57 for the studs. Okay. So this is kilopascal or kilonewton per square meter. So in terms of pressure. And then for the fiberboard, we have that one to be equal to fiberboard 0.04 and clay brick is 1.87. So this is 0.04 and this is 1.87, both in kilopascal. Okay, so we shall now compute. So for the stud plastered on one side, all we have to do is to multiply this one by the height. Okay, so all will be multiplied by its height. Alright, so the corresponding dead load here we have a height of 2.5, so dead load is 0.57 times 2.5, and then for this one 0.04 times 2.5, and for this one 1.87 times 2.5. So we have here equal to 1.43 kilonewton per meter. Alright, for this one we have 0.02 kilonewton per meter, and for the last we have 4.68 kilonewton per meter. So we'll just total that. So the total dead load for that wall is the sum. We have 6.125 kilonewton per meter. So this is the answer for that. Okay, so let me correct this one. .04 0.04 times 2.5 is 0.1 supposedly. Okay, sorry for that. 0.1. So recalculation, we have 6.21 of 6.21 kilonewton per meter. So this is the answer. Thank you.